All right, the last thing we need to talk about in this section is the Taylor series. So far we've been doing Maclaurin series, and Maclaurin series are centered at 0. A Taylor series, though, can be centered anywhere. And so in that sense, a Maclaurin series is a special case of a Taylor series. But if you have a Taylor series centered at A, the formula for it is this. You got C0 plus C1 times x minus A, and then your coefficients continue to go up, and it's x minus a that's raised to these powers. And the Cn, the way you get that is by taking it's the same as before with the Maclaurin series, but you're evaluating this derivative at a instead of at 0. So I want to do an example here and show you what the difference is with the centering. So let's look at this Desmos. I'm going to make this full screen. Give me a second. Or at least I'm going to make it bigger. All right, so what we've got there is e to the x, and I've got the series for it, and it's centered at 0 right now. If L gets big, then this becomes a really good approximation, and the approximation is perfect at when x is 0. So even if we zoom in, even this really bad approximation, which is a horizontal line, it's exactly correct there at 0. And it's exactly correct for, small values of L. So if we wanted to change this so that it was centered at, say, 1 instead of 0, let me change the step here to 1 so we can see it. If we wanted to center it at 1, it would be perfect right here at 1. And the way we do that is we'd have to, instead of just x raised to a power, it'd have to be x minus 1. But we'd also need to have not just changing that, but we also need to evaluate our derivatives here at 1 instead of at 0. So what is e to the 1? Well, it's just e. So if I go back in here, and right now there's a coefficient on the front of this that's a 1. If I change that to an e, then the approximation jumps up here, and now the approximation is perfect right here at this point. And if I start to make this L grow slightly, the approximation is centered there at that point now. And of course, when L gets big, the approximation is good everywhere. If we wanted to, let's say we wanted to center the approximation over here at -1 instead. What I do there is I do x minus -1. Better way of writing that is x plus 1. And I'd have to replace this with e to the -1. And now we've got our approximation centered there. And if L grows, then it's going to get better and better. So usually we tend to use Maclaurin series over Taylor series because they tend to be easier to calculate. And in a lot of cases like this, where your radius of convergence is infinite, it doesn't really matter where you center it. As long as you use enough terms, the series is going to be sufficiently close to the actual function. So anyway, that will do it for this section.